Alright, now this is question 4. This question 4 is about Kirchhoff law. Kirchhoff law for chapter 3. DC circuits. So the internal resistance of all the batteries are negligible. So no internal resistance. Calculate the currents I1, I2 and I3. Okay, I1, I2 and I3 when the switch S is open and closed. Yeah, open or close. Okay, look at the first one when the switch is open. Okay, you see when switch is open, it becomes only one loop. When this switch is open, it becomes only one loop, which is the outside loop. Yeah. So right here. So when a switch is open, it only has one loop. One loop. It becomes only one loop, so it only has one current. Okay. There's no I2, I3, I1. It's only I only. Yeah. Only one current. Yeah. There's no multiple current. There is no multiple current. Okay. So we must redraw the diagram. Okay, which is the outside loop. So this is how it looks. Okay. So and then we must label the direction. We must label the direction. So for EMF, we look at terminals. Okay, negative to positive. Battery is negative to positive direction. Okay, and then the direction of current normally is from big battery to small battery lah. So we can see this 12 volt is bigger than 9 volt. So current we push from 12 to 9. Yeah, instead of 9 to 12. The current should be pushed from 12 to 9. So the current should push from 12 higher potential to lower potential. Only one current. Draw the current at all the resistors. Yeah, draw the current at all the resistors. Because battery depend on terminals negative to positive, but resistor depend on current. Okay. And then for one loop. Okay, for one loop, so you see I3 when open, I3 becomes 0, and then I1 is equal to I2 equal to I lah. As I said just now, one loop only one current. Okay, so they are I1 and I2 is the same current. Yeah, I. Okay, and then for one loop, there's no junction. So no need to apply Kirchhoff's first law. Current in, current out, no need. Yeah, current in, current out, no need. So only the Kirchhoff's second law. Only one equation needed. Okay, so total E go to total IR. So loop 1. So we choose our loop. We try to choose our loop, follow the current. Yeah, follow the current. So this case I choose clockwise. Okay, clockwise. This is our loop 1. Okay, so follow the current. So so here, yeah, go like this, clockwise. Okay. So now let's look at total EMF. Total EMF, we have 12 and 9. So 12 is same direction with the loop, so 12 is positive. Okay, 12 is positive, and then 9 is opposite. 9 volt is opposite to the loop, so they get negative 9 if opposite direction negative. Okay, and then resistance. Then now we look at resistance. Resistance look at current. Just now EMF look at terminals negative to positive, but now resistance look at current. So resistor, we have 2 resistor. Okay, so let's start with 7 ohm. 7 ohm, the current I is same direction with the loop, same direction. So 7I is positive. 7I is positive. And then 8 ohm. 8 ohm, current I. Current I, same direction with the loop, same direction. So also 8I positive. Okay, 8I positive. So now we have this equation. We solve it. We get the current. Current is 0.2 ampere, which is equal to I1 and I2. Okay. So we also accept negative answer lah if you get negative current. Okay, negative current if you put the loop anti-clockwise, opposite, then you get negative current. Yeah. So this is the answer. Yeah. Yeah. So this is the answer. Yeah. Okay. Now, for second question, if the switch is closed, what happened? When this switch is closed, and then it become two loops. You see, become two loops. We must redraw the diagram. When the switch is closed, it become two loops. Two loops. Yeah. So if you have two loops, remember that if you have two loops, meaning if you have two loops, then you have three current. You have I1, you have I2, you have I3. You have three current. Remember that. Okay. Then you need to apply Kirchhoff's first law. Okay. So okay, let's label the direction. Okay, label direction. Battery negative to positive. Battery negative to positive. And then label the current I2, okay, going down. So I2, label the current at the resistor, label the current at the junction, okay, label the current at the resistor, label the current at the junction, label the current at the resistor, label the current at the junction, okay, and then we put this as junction A, this is junction B. We have two junctions, okay. So okay, done. We already labeled the current and also the EMF direction, negative to positive. Now apply Kirchhoff's first law, which is current in, current out. Choose junction A. Junction A, current in is I2, yeah. Current out is I1 and I3. So I2 equal to I1 plus I3. So you get one equation, 1 marks, okay. Now, then we do Kirchhoff's second law, total E equal to total IR. So, so we choose two loops, okay. We choose, let's say the first loop we choose here, yeah. We choose this one. We choose here, okay. Clockwise, loop 1, and then this is loop 2. We choose this one, yeah. Loop 2. Yeah. This direction. Okay. Both loop we choose clockwise, okay. Now okay, now so let's look at the loop 1, yeah. Let's look at the loop 1. So in loop 1, yeah, along this loop 1 we only have one battery, but this battery is opposite direction to the loop, opposite, so negative 9, so it's negative, see, negative, because why? Because they are opposite direction. Negative 9, this EMF is opposite to the loop, so negative 9. And then no more battery, you look at resistor we have 8 ohm and 4 ohm, okay. So 8 ohm, the current pass through is I2, and so I2 is same direction with the loop, same direction. So positive 8I2, okay. And then how about the 4 ohm? 4 ohm, the current passes through is 4 ohm is I3. I3 is same direction with the loop, so positive 4I3. So we got our second equation, okay. And then the L2 is okay, L2, let's look at L2, loop 2 clockwise, clockwise. So what's the EMF? The 12 volt, only one battery, 12 volt. And then 12 volt is same direction with the loop, okay, same direction with the loop, to the left, same direction with the loop, so it's positive 12. And then how about no more battery? Now resistor we have 7 ohm and 4 ohm. Okay, let's look at 7 ohm. 7 ohm current passes through is I1. I1 is same direction with the loop, same direction, so positive 7 I1, okay. And then how about 4 ohm? 4 ohm, the current passes through is I3. Oh, but I3 is opposite to the loop. I3 is opposite to the loop. So it's negative. Negative. So remember to put negative if opposite direction. Okay. I3 and you see opposite direction to the loop. So negative 4I3. Okay. So we got our third equation already. Okay. So we must have three equation. We have 1, 2, 3 equation here. Now we rearrange them. We rearrange them in sequence. Yeah, in sequence. That means we arrange them in 1, 2, 3, 1, 2, 3, 1, 2, 3. Then solve by using scientific calculator. The matrix method. Remember? Okay. So question for equation 1. We rearrange become I1 minus I2 plus I3. Yeah. But equation 2, we don't have I1. We don't have I1. We need to put 0 I1. Like equation 3, we don't have I2. You see, we don't have I2. We need to put 0 I2. If you don't have, you must put in 0 I1 or 0 I2. Okay. So arrange 1, 2, 3, 1, 2, 3, 1, 2, 3. Then you type in the calculator using equation unknown 3. Then you get this answer I1, I2, I3 directly. Okay. So each of these you get 1 mark, 1 mark, 1 marks. Yeah. Okay. Don't be afraid if you get negative current. Negative current just means negative current is not wrong. It's not wrong. Negative just shows the direction. Yeah. It just means the direction. It says that negative, if negative means that the actual current direction is opposite to the one you draw. Okay. That means the actual current direction is opposite to the one you draw. Let's say I2 is negative. You get I2 negative means what? Because you draw I2 is going this way, right? This is the direction you draw. Like I2 is going to the right. So if you get negative I2, it means that if negative I2, it means that the actual direction is to the left instead of to the right. The actual current direction. Okay. And then for I3 also you get negative. I3 also get negative means okay. Just initially you get I3 to the left. Yeah, moving to the left. So this is the direction you draw to the left. But the actual direction, since you get I3 negative, means the actual direction is to the right. So the actual direction actually is to the right instead of to the left. So the blue one is the actual direction. The blue one is the actual direction. Okay, thank you.